Today I'd like to talk to you about my experiences building and using a Prusa Mini clone. This is a kit by Fysetc. Fysetc are a Chinese company. I think it's pronounced Fysetc. It's hard to say really. Fysetc seems like a good hand at Scrabble. Not necessarily the best name for a company. It's not what you want to sell into the UK for. I was a little bit concerned about buying a clone of the Prusa product, and if anybody from Prusa is watching, I would just like to say that I would actually have loved to have bought Prusa original Mini 3D printer. The idea of buying a clone did leave me a little bit iffy. Wasn't really too sure what the term clone actually meant. Was it going to be the same components and parts sourced from China, or were they just going to be buying some equivalents and then hoping they all kind of worked? The reason that I decided to go down that route was largely because, much as I say, I'd love to have bought the original Prusa Mini 3D printer. I mean, everything about Prusa sort of says quality, and it seems like a very nice company to buy from, but it's very simple. There were two reasons. First of all, the spat between the UK and the EU, this whole Brexit divorce thing, and their equivalent of who's going to get the dog, made me feel that it was very, very likely that I was going to get truly shafted on the duty and the admin fees from the couriers to ship the printer to the UK. So that was item one. The second item was the simple fact that there was a 14-week lead time on the Prusa website. Now, I'm a patient guy. If you're going to be getting involved in 3D printing, you need to be a patient person. Nothing really happens very quickly with a 3D printer. They take hours to do the prints. If you're not patient, it's just not the kind of thing that you want to be getting involved in, really. 14 weeks is too much. Even I'm not going to wait 14 weeks for a toy. And this is not going to be for commercial purposes. It's very simply something that I want to use to make fun things with. Which also sort of brings me back to my price point, my budget. Very simply, my purpose in buying this printer in the first place is to build an authenticate Spitfire Spade joystick controller. I considered how long. I considered whether it would be worth just buying the bits, getting somebody else to print them for me. And when I looked into it, it appeared that to do this would probably cost somewhere in the region of 150, 175, maybe as much as £200 to get somebody to print the parts for me. So I thought to myself, well, £200 I can buy myself a 3D printer, I can print the parts myself, probably for a few quid, and then I've still got the printer to print anything else that takes my fancy. So it seemed like a bit of a no-brainer in that respect. So €325 for a Prusa Mini printer would have been fine, but I figured that by the time I'd gone through all the taxes and the admin fees and all the other kind of nonsense that's cropped up since the whole Brexit thing has gone through, that just seemed like it would be sort of pushing maybe £500, and that was just too much. So £500, 14 weeks, wasn't going to do it. So I decided to take a punt, bought this kit off eBay, which was very good. The nice thing about this particular kit, normally with Fysetc, you get the parts. So you get the mechanical parts, you get the electronic parts, nuts, bolts, screws, wires. It's this massive cardboard box just full of stuff. It's quite daunting. What you don't get with the Fysetc kit is you don't get any of the plastic printed bits, which is a problem because it effectively means you need to have a 3D printer to print the parts you need to make the 3D printer, which to my mind just seems bonkers, but that's the way it is. And it's not like you can print it on a 3D Mini, a Prusa Mini 3D printer either. It would need to be quite a substantial 3D printer because a lot of the bits to make the 3D Mini are they're bigger than the print area, as you can imagine. So That's a bit of a problem. I mean, you can get people to print them for you in the UK, but it's quite expensive. You can buy the bits from China, pre-printed. I have no idea what sort of a lead time you'd be looking for if you're buying it from China. Buying it from the UK would be pretty quick, I imagine, but not cheap. So, you're sort of coming back again to, probably the £325 if you're to buy it that way. I got lucky. I bought the kit for £225 from a guy from eBay. He's very good. I haven't been the easiest customer in the world because every time something's gone wrong with this build, which has been fairly frequent, I've let him know about it. Not because I want him to fix it, just purely and simply so that if he's going to be selling any more of these, he will know what issues that he's going to have to contend with people, coming back and throwing at him potentially. I would like to say that none of the issues that I've had, and there have been a lot, none of the issues have been caused by him. Mostly the issues have been either caused by just tolerances with 3D printed parts, which is just one of those things, things not fitting into holes properly, and the other issues have been issues of either manufactured by Fysetc, or more often than not by Fysetc changing some part but not telling anybody, or if they do, they put it in the small print and probably in Chinese, I don't know. I didn't spot them until I started trying to put things together and then realising that things didn't fit, so that was a problem. The chap I bought it from solved one issue for me, which is the LCD screen surround. That was the wrong size, and he printed me off a new one. I found the print, sent it over, he printed it for me and sent it through me, and it just came like the next day, so that was really, really good. I was very impressed by that. So yeah, as you can hear, quite a few problems. This is not going to be a build for somebody who is not capable of sitting down and fiddling about with the components to try to overcome the problems that pop up. I'm going to take you through the problems that I had. Can't guarantee that these are going to be the same problems that you have, I'm assuming you will. But at least you know what sort of things I had to contend with, so you will know ahead of time what sort of things you might have to prepare to fix. That's the purpose of this video. Go TLDR, it's probably a bit too late to do TLDR, we're quite a way in, but TLDR, I am very happy with the product. I'm very happy with my Prusa Mini clone. It was a bit of a bugger to build. That's the takeaway. So I'm going to take you through all the bits and pieces that I had problems with now. Okay, so this is the machine that I bought. As you can see, it's turned on, it's ready to go. I've just printed a little part for the Authenticate Spitfire stick. These are the other parts that I've printed. They're a funny shade of yellow a lot of the time because I've sprayed them over with a primer. But by and large, they're coming along okay. I've had to do quite a lot of fiddling around to try to get everything to work right, but that's all part of the fun. This is the part that I've just printed. This is to hold the fire button onto the what I think was the dog toy, but the little circular handle. As you can see, it's a reasonably tidy print. I'm quite happy with it. But I'm just going to turn this machine over and show you some of the issues that I've had. I'll take you through them in more or less chronological order as they kind of pissed me off. Okay, so I've got the printer tipped over on its side, as you can see. So the first issue that I've had is concerning this mounting plate here. Now, as you can possibly see, this has got two linear bearings on this runner at the top, and then it's got a third linear bearing on this bottom runner here. This mounting plate is the plate that the hotbed attaches to, and then the printing bed attaches to that with magnets on top. Now, this is not the original Prusa design. As you can see, it's got two little sort of risers there, or well, so it's got about 9 risers, I think, in total. These are moulded in with threads, whereas the original Prusa, you had to actually screw little risers in to do the same job. So in many ways it's a better design. The problem is with these little U-bolts just here. Those little U-bolts there. Well, it's not really the bolts actually. The problem is with the screws for the U-bolts in the plate, which are the holes are approximately 0.5 millimeter too far apart. So it means that when you go to put the U-bolt through, it doesn't go. And my eventual solution to this was to get a drill with a drill bit that was the same size as the hole, and just basically grind it in towards the other hole, so that it just brought the interior corners of them, or interior surface, slightly closer together. But it took me probably about 2.5 hours to figure out that this is going to be the best solution, not least because I wasn't particularly keen on drilling a hole in a brand new piece of kit when I wasn't at all sure what function it actually had in the 3D printer, because I didn't know if this was going to affect the bed leveling or any of the calibration or those sorts of things. But anyway, that was my solution. The next issue that I had is with this little fella here, which is the piece of plastic that holds the belt idler. The problem I had here, as I think I mentioned a little while ago, is that the print tolerances are not always good enough. And this little hole here where I've got my finger, what you can see, that silver bit, is actually a square nut that just sits inside that that plastic, inside that little slot. And basically these two bolts here screw into the little nut and hold this to the body, which is all very straightforward, except the hole wasn't big enough. And because the hole wasn't big enough, it meant that trying to get those nuts in was an absolute nightmare. In the end, I found out that it was easier to actually grind the nuts down so that they were small enough to go in the hole, rather than to try and file the hole big enough for the nut to go in it. Trying to file PTG in those circumstances is, it's virtually impossible. It's just a nightmare. Okay, so those are the two first problems that I hit. So the next big problem that I hit, is trying to get the camera around to the right angle, is to do with this. Now, you remember that I said that a lot of the problems that were caused are due to Fysetc changing a part and then just not telling anybody about it. So this orange piece of plastic here is a 3D printed piece of plastic, which basically contains, contains the workings for the extruder. This motor bolts onto the outside and drives the extruder, which is, try to see it, which is in here. If you lift this little flap, you can actually see the gears of the extruder inside. Now, that is shown in the plans as being a 6mm easy connector. It seemed to be a little bit ironic in the circumstances, given that it took a huge amount of fixing. It wouldn't have taken a huge amount of fixing, except for the fact that I didn't have a 9mm drill bit. This is actually a 9mm easy fit connector. So you've got two options. You can either order up a 6mm one, which is what the hole is actually originally designed to take, or you can drill a 9mm hole and just screw the bugger in, which is the option that I went for. Again, you'll see these all over the place. These are all the little square nuts. Again, a lot of the time they don't quite fit, and depending exactly where they are depends on how difficult it's going to be to actually, work around that. I think I already mentioned this, the fact that the casing for the LCD display was slightly, it's the wrong size. So basically there were two size screens provided by Fysetc. One of them is, I think one was a 2.8 inch and the other one's 3.2 inch. Not a huge amount in it, but obviously the screen casing isn't going to fit if you get the wrong one. This is why this is black and everything else is, sort of mostly garish orange. It's because I just asked the chap to print me up a black one instead of an orange one.
So an easy fix really, but took quite a lot of research to work around it. Next issue is, you can't really see it all that well. You can see that you may be able to see there's a couple of splits here and there. Certainly I managed to split the casing a little bit when I was drilling the hole for the connector. But the next thing is really a generic issue, and that problem is just don't over tighten things. Really don't over tighten things. Unfortunately, of course, you won't know when you over tighten something until you've over tightened it, and then it just cracks. It tends not to give you an awful lot of warning. A particularly good example of this is this little device here. Okay, this printed part is the Minder holder, and this thing here is the Minder. I have no idea what Minder stands for, other than the Min stands for Mini. Normally it's a Pinder, which is, I guess, something Prusa related. But basically, long and short of it is, it's a distance sensor. It works out how high the hot end is off the print bed. Now, that little thread of filament, and this is held in place by this piece of plastic here. Now, when you first attach this, as you follow through the instructions, you connect this nut first, and then you basically get all these cables behind the little sort of hollowed out part at the back here. But there's not an awful lot of space. And these cables are actually pretty tough, they're pretty springy, they're pretty resistant to being bent round. So what ended up happening was I bent them around as best I could, got them as flat as I could, bolted this thing on, at which point it promptly snapped. You can probably see just there, that's where I've superglued this back together. And the only saving grace is that superglue does actually work very well on PETG. And then I strapped these down with elastic bands to basically force them to conform to the corner that they've got to go around behind this little piece of plastic. And when they sort of nicely conformed and this had sort of set, the superglue had set, I put it back on very, very, very lightly. This one, really do not over tighten this. Do not over tighten it, because I'm pretty sure that's the main thing that causes it to crack. And once it cracks, it's really difficult to get it to work. Oh, I know, lost something there. To stop it from breaking again. Later on, you get to attach this here, which basically adds a little bit of structural strength and stops the whole thing just breaking again. But like I say, by that point, you're probably already in trouble. So far, fortunately, fingers crossed, nothing worse has happened. Okay, that one did take quite a lot of fixing. Okay, so that is almost it. The only last thing that I would really sort of point out would be this little fella here. This is not really a fault per se. I'm not really sure what I would classify this as, but the idea behind this end piece is it's an idler, but also if you look in the end, you can see that there are a couple of little screws. The only purpose of those screws is to act as a tensioner for the belt. So the idea is that when you construct this, you put this end cap on, you push it as tightly as possible onto the end of this runner, and then you put the belt into position. So we'll slide this for you. Okay, so you can see in there that there's like a little toothed bit that the belt connects into. That's what holds the belt, and you get that as tight as you possibly can, and then you slide it into the teeth. Now the belt has no give in it whatsoever. It's sort of some sort of rubbery, plasticky stuff, but it has absolutely no give whatsoever. So you pull that in as tightly as you possibly can, and then once you've got it in to the nearest tooth, then you go to this end bit and you tighten up the screws in the end of here, and the idea is that that will push this backwards and tension the belt. I don't know why, but that didn't really work very well for me. When I tried to do this, there was no significant difference. In the end, what I actually ended up doing was slackening off these screws here and here and here and there, that one there, and then just literally pulling the whole thing away from the vertical, away from this thing, until the belt was nice and tight, and then I just retightened these screws. That seemed to work. I was a little bit worried that it might mess up the calibration, but it doesn't seem to have done so, so that's very good. Okay. And that is the last of the major problems that I've had with it. The last one, if I were to call it a problem, is really just the fact that this box here, this contains all the electronics, and that is very, very, very tight. This thing here that's sort of waving around like a spare part, because it kind of is a filament detector. Unfortunately, as far as I can tell, this has absolutely no use whatsoever. I don't know if it's broken or if I've wired it in wrong, but what I do know is that I am not brave enough to open up the cable box and either turn the connector around, which might make it work, or just remove it altogether. I am not opening that connector box unless I absolutely have to. Those cables are jammed in there as far and hard as they can be. And I've got a feeling that opening them up is going to just result in like some sort of eruption, like a jack-in-the-box coming out. Okay, so that's my review of the Prusa Mini clone. I hope that will prove to be of use to you. If you have any issues building yours, if you decide to go for one, then please pop the results in the comments below. Likewise, if I come across any other issues, then I'll stick those in the comments as well. Overall, the printer itself works very, very well. I have had a small problem today where I've been trying to print a volume knob, and for some reason it's ended up like this. All slightly deformed, beautiful printing on the bottom, but all deformed on the top. First time I've had any kind of issues like that. I was a bit worried that the printer had managed to get out of whack when I turned it over from doing this video, but in actual fact printed another piece, which is this bit here, and that has printed beautifully. So obviously not a printer issue in that respect. There's obviously just something about the way that that little knob is sliced, or the settings, maybe the temperature is wrong or something like that, that is causing that particular issue. Anyway, I hope that this video has been useful, and like I say, if you have any comments, leave them below. Thank you very much.